If you have an exponential function y equals ab to the x, how would you find the inverse of it? So if you go back to inverse functions, what we would do is we would switch the x and the y around. So x equals ab to the y and solve for y. But we don't have a way to solve for y. We don't divide by a. We could not divide by ab. We couldn't take the y through of each side. There's no such thing as that operation. So what we have is what's the inverse of an exponential function is called a logarithmic function. So the logarithm is the inverse of an exponential function. A logarithm is a new type of function. You can go back and forth between an equation written in exponential form and logarithmic form. The base of a logarithm is the base of an exponential equation. So if you have the exponential equation y equals a to the x, we can write that in logarithmic form. It's going to be the logarithm, or we write it as log, of base a. So base a is a subscript letter, it's a lower level, of y equals x. These two are two equivalent statements. So I can write something in exponential form and logarithmic form. So down here in this chart, I'm going to go back and forth between exponential form and logarithmic form. So I'll push it down here so you can see up top. So in this first one, my log is base 2. So that means my exponent is going to have a base, or my exponential form is going to have a base of 2. The power is on the other side of the logarithm. So it's going to be 2 cubed equals x plus 1. So I went back and wrote it in exponential form. Now the second one, I can take something in exponential form and write it in logarithmic form. So I write log. Now the log has a base 6 because the base of the exponent is 6. So I write a subscript 6. And then it's going to be y equals x, because the number that's by itself on the opposite side is the exponent. Okay, the number or variable. Third one, so it's going to be 3, because that's the base of the logarithm to the x, equals 12. This one's going to be log base 3 of x equals 12. And then the last one, y equals 10 to x, we're going to write it as log base 10 of y equals x. So that's how you go back and forth between writing in exponential form and logarithmic form. So down for number 2 down here, these are these are inverse functions. So these two functions, y equals 3 to the x and y equals log base 3 of x, are inverses. Okay, so if you can graph y equals 3 to the x, you remember with an inverse function, you switch the x and the y around, and that will help us graph the log base 3 of x. So I'm just going to fill in this table. So this table, if I take 3 to the negative 2, remember that's 1 over 3 squared, so that's going to be 1/9. 3 to the negative 1 is 1 over 3, which is 1/3. 3 to the 0 is 1. This will be 3. 3 squared is 9. 3 cubed is 27. So knowing that these two functions are inverses, I can just switch the x and the y around. So my x's, or my y's, are the x's over here. So 0, 1, 2, 3. And this is going to be 1/9, 1/3, 1, 3, 9, 27. So over here, I'm going to graph both of these functions. So I went ahead and graphed the red function as the logarithmic function, or as the exponential function, and the blue function as the log function. So you can see that they are inverses of each other because they are reflections over the line y equals x. Okay, so remember, inverse functions, you can reflect them over the line y equals x. They are both functions. They both pass the vertical line test. So the domain of the exponential function is going to be all real numbers. So exponential function, the domain is going left and right infinitely. So the domain for the exponential function is all real numbers. And the range, because there's an asymptote at y equals 0 for the exponential function, is going to be y is greater than 0. Now, contrast that with the logarithmic function. You'll notice, remember, that the domain is the same thing as the range of the inverse function. So the range, so the domain right here is going to be x is greater than 0 because the function is, this is your vertical asymptote, and the function for the domain is to the right. So the domain, the x's are never negative in this function. So the x is to be greater than 0. And you notice that the range right here is y is greater than 0. And then so therefore, the domain of y equals 3 to x is all real numbers. So the range of the inverse is all real numbers. Okay, a couple more graphs to practice over here. Log base 5 of x. So what you can do is you can think about graphing y equals 5 to the x. So if I make a table of y equals 5 to the x and put in -2, -1, 0, 1, 2, and then this is going to be 1 over 25, 1/5, 1, 5 to the 1 is 5, 5 squared is 25. So my function for the logarithm is basically flipping it around. So my x is going to be 1/25, 1/5, 1, and 5. And 25 is not fitting. And then this is going to be -2, -1, 0, 1. So I'm going to plot these points. So I plotted the points, connected them with the curve. Notice how there's arrows at both ends. So now the asymptote is the equation of the line where the log doesn't cross. So it is not crossing this vertical line. So this vertical line is the equation x equals 0. Asymptotes always have equations. The domain is going to be all the numbers to the right of 0. So it's going to be x is greater than 0. And the range is the function is going up and down infinitely, so it's going to be all real numbers. So the second one up here, or the third one actually, to graph y equals log base 2 of x, you want to make a chart. So make your chart with the x and the y. And you're going to actually graph y equals, or you're going to make a chart for y equals 2 to the x, -2, -1, 0, 1, 2. Plug in 2 to the x, so it's going to be 1/4, 1/2, 1, 2, and 4. And then your logarithmic function, you're going to flip them around because they're inverses. So this is going to be 1/4, 1/2, 1, 2, 4, -2, -1, 0, 1, 2. So I'm going to graph that. So I plotted my points, connected the curve, put arrows at the end. Notice again you have this asymptote that's a vertical line. So this vertical line is x equals 0. In the domain, all the values to the right of the function is going to be x is greater than 0. And the range is all real numbers. So down here, if you have to solve or evaluate logarithms without a calculator, what you want to do is write it in exponential form. So if there's an equal sign, or I'm trying to figure out what this thing is, what log base 2 of 32 is, I write equals x. Now I write in exponential form. So exponential form is 2, because that's the base of the exponent. Over here is the exponent. 2 to the x equals 32. and then you have to solve for x. So what number, or 2 to what power is 32? The answer is 5. 2 to the 5th is 32. Okay, second one, put an x right here. 6 to the x equals 36. What does x have to be? 2, because 6 squared is 36. Third, 5 to the x equals 625. 5 to the 4th equals 625. And then next one, 3 to what power? X equals 27. So x has to be 3. 4 to the x equals 64. X has to be 3. And then 8 to x equals 1 over 64. Okay, in this case, there's a denominator. 64 is in the denominator. So that means that I must have a negative exponent right here in order to put the 64 on the bottom, 1 over it. So x has to actually be negative 2. So negative 2 right here. Next one, 81 to the x equals 9. So how do you go from 81 to 9 with the power? Well, the square root of 81 is 9. So if you remember, the square root is actually taking something to the 1/2 power. So the answer is 1/2. 13 to the what power equals 1? Well, anything to the 0 power is 1, so the answer has to be 0. 25 to what power equals 625? Well, 25 squared is 625, so x equals 2. Or I should just write 2, not x equals. And then these get a little more complicated right here. So I have 27 to the x equals 1 over 81. So some different things are going on that I'm going to have a negative exponent. Another thing I notice is that this isn't a power, I can't do 27 squared, 27 cubed. So what I'm going to do is recognize that both of these can be written as a power of 3. So the technique is take 3 and write it as 27. So it's going to be 3 cubed to the x. So using properties of exponents, this hasn't changed anything. This is 27 to the x power equals, how do I write 81, 1 over 81 as a power of 3? Well, 3 to the 4th is 81, so this is going to be 3 to the negative 4th power. Now I'm going to set these two equal. So I have 3x equals negative 4, so x is negative 4/3 is my answer. Or I should just write it as negative 4/3 because there's really not an x in the problem. Okay, another one is 8 to the x equals 32. So I can't write 8 as a power of 4. I can write both of these as powers of 2. So this is actually going to be 2 cubed to the power of x equals 2 to the 5th. By setting these two equal, 3x equals 5, because they have the same base, x has to be 5/3. And then down here, I have 16 to the x equals 1 over 64. You can either rewrite these as powers of 2, because I can write both these in powers of 2, or powers of 4. I'm going to do powers of 4. So this is 4 squared to the x equals 4 to the negative 3. Okay, negative 3 powers. So this means that x equals negative 3/2. Or negative 3/2 is the answer.